Hi viewers, this is Sri Ramlu. So today's topic is superconductivity or superconductor. Superconductivity. So definition: when a substance loses its electrical resistance, that is, a current can continue through it without altering its value. The phenomenon is known as superconductivity. Here, when a substance loses electrical resistance means resistance of that substance must be zero. That is, so when resistance zero, what happens? Current can starts flowing. Okay, so current can continue through it without altering, means without changing, without altering its value, without changing any values, any number in its value. This phenomena, this process is known as superconductivity. So that is a definition, one definition. So next, one more definition you can write in the examination, either this definition or this definition. So that is your wish. So which definition it is, which is easy for you, so learn that one and write in the examination. But here listen both definitions. When the electrical resistance of a substance drops suddenly to zero, when its specimen is cooled below a certain temperature, the phenomenon is known as superconductivity. When electrical resistance of substance drop suddenly to zero, so its resistance is becomes zero. When resistance zero, when its specimen means substance is cooled below certain temperature. So when the temperature is lowered, suppose it is one normal conductor, what I am doing, I am keeping it is in a lower temperature, or I am decreasing the temperature of this substance slowly. Then what happens? At a certain temperature or at a particular temperature, what happens? Its resistance completely zero. Then what happens? Through it, current can flow forever or continuously. This phenomenon is known as superconductivity. So such a process is called superconductivity. The substance showing this property is called as a superconductor. So which substance can show the above property? That substance we simply call as superconductor. So example for the superconductors here, examples are silver, it is a conductor, lead, gallium, iridium. So these are the conductors. The temperature at which resistance disappear is called transition temperature or critical temperature. See here, what I'm saying in this definition, at below a certain temperature, this certain temperature is simply called critical temperature or transition temperature. See definition, the temperature at which the resistance disappear is called. So where resistance disappear means the resistance becomes zero. So explanation. What are the explanation? What is the explanation? The electrical resistance of an ordinary metal is due to the collision of conduction electrons with vibrating ions of crystal lattice. So crystal lattice means inside the crystals, like this lattice points are arranged. So these lattice points are positive ions. They always vibrates about their mean position, either like this or like this. So any one direction they vibrates. And electrical resistance of an ordinary metal is due to, so resistance, what resistance is because of what they are saying, because of collision of conduction electrons. So conduction electron means which electrons can constitute current, those electrons are called conduction electrons. So what happens, suppose one electron is moving like this and another electron is coming in this manner, then they what happen, they start colliding here. When they collides, their direction changes, they cannot flow in single direction, then their resistivity increases. In superconducting state, the electrons scattered in pairs rather than individual. So in superconducting state, electrons scattered, so they move in different direction by paid. So they cannot go move in any direction singly individual. They moves with a paid. So two electrons like this, two electrons can move, but cannot can move single electrons. That is individual electrons. This gives rise to an exchange force between the electron. So what happens, suppose these two electrons are moving in this direction, then these two electrons can exchange, means share the energies. So our forces, they can easily share the forces. This force is similar to force between the nucleons in a nucleus. So inside the nucleus, so many protons neutrons present, right? Protons and neutrons present. And then what happens, so proton or neutron proton, they exchange forces, that is the nuclear forces. Like this, here electrons also, paired electrons also, they exchange always forces between them. When electrons have opposite spin and momenta, there is a very strong attractive force between them. In superconducting state, the forces of attraction is greater than the electrostatic force of repulsion. Once again, see, when electrons have opposite spin, so one electron is spinning clockwise, another one is spinning anti-clockwise, then see, and if they have the momenta, there is a very strong attractive force. What happens, a strong attraction force will create because of because of opposite spin and containing momentum. So then they create a strong, very strong attractive force. So because of this attractive forces, two electrons always move by pairing. Okay, in superconducting state, force of attraction is greater than the electrostatic force. So generally electron and electron, which force they have, always they have the repulsion force. Why? Because they are negatively charged particles. But this repulsion force is what, simply electrostatic force of repulsion, that is. But this force is dominating, so that means more the forces between the forces between the two electron is very much greater than this force. So that is why they cannot move away from each other, they always move by pairing only. Thus, all conduction electrons become bound system. So like this, all the conduction electrons are, they bound easily. Now, no transfer of energy takes place from this system to lattice ion. So because of this only, like this lattice ions are arranged, and because of presenting this strong force, they cannot exchange this. They cannot give the energy to the this lattice points or positive ion cores. When an electric field is applied to a substance in superconducting state, pairs of electrons gain additional kinetic energy. See, once again, they gains additional kinetic energy. When electric field is applied, suppose I am applying the electric field, okay, to a substance in superconducting state. So it is a substance in superconducting state. Pairs of electrons gain. So these superconducting states containing always paired electrons. These paired electrons gains additional energy because of this. This can push the electron in single direction. Then they gains more energy. That is a kinetic energy. Thus they give rise to a current. So that means they gives a current. Like this, they gives a current. These electrons do not, so sorry, it is do not transfer any energy to the lattice. So they cannot give any energy to the lattice, hence they do not get slow down. So that is why they cannot come slowly. When they come slowly, their resistance increases, but here resistance is zero. As a result, this substance doesn't possess an electrical resistivity. So because of this only they cannot come slow down, so they move always in single direction with the same velocity. So that is why their resistance cannot be more, so their resistance is always 0. It means resistance of superconductor is 0. That is resistance of the superconductor is 0. Okay friends, don't forget, but here simply one mistake is it is do not a don, so only do, so please correct it. Thank you friends.